So hello everyone. Today we are going to be presenting the FLO-2D Tailings Dam Tool webinar. It's a long time since the last presentation for this tool, and the tool has been updated and have changed in the last months. Um, if after the webinar you have any question or you need to contact me, my email is on the first slide of this presentation. As you know, the tailing dam, a tailing dam facility is basically an structure that represents a potential cost to the owner rather than an asset like the water facilities. So with this tool, the tailing dam tool, we try to develop a screening tool, an application. We develop an application that help us to estimate the occurrence of the tailing dam failure based on different failure modes, 3 failure modes, and also estimate the most probable failure based on documented failures worldwide, and estimate the failure release volume. So that's basically the product that this tailing dam tool produce, and I will talk extensively about this today. With the FLO-2D model, there are different options to simulate a tailing dam failure in FLO-2D. And if you want to let the FLO-2D model to bridge the tailing dam facility and calculate the release volume using the hydraulics and the rheological properties of the material and the dynamics of the mud flow, then the tailing material needs to be added to the FLO-2D simulation, as you can see in my image here in the slide. So if you decide to go that way, you will need to enter the tailing dam material into your FLO-2D domain, and assigning that tailing dam material to the domain, you will need to also enter some data regarding the tailing dam material and the reservoir water, the tailing thickness. If the tailing thickness is well known and is variable on a space, you will need to enter one tailing thickness per each cell, and you will also need to enter some rheological properties and mud flow sediment transport parameters. And once you enter all these data, so it's a lot of additional data that you need to enter, the model, you will need also to decide how you want to model the bridge of the tailing dam facility. FLO-2D allow you to simulate different failures modes, like piping, overtopping, complete collapse of the tailing facility, stack failure. And that is also additional data that you need to enter for the failure location, and also the type of failure that you are allowing the FLO-2D to use. Once you enter all this data, you can use the two-phase flow component that is a pretty recent component in FLO-2D. Well, it's already 2 years or 3 that it has been in FLO-2D, but it's the latest component that we have added to the FLO-2D model. And using that two-phase flow component, you can route the mud flow downstream in the domain. So this is one way, one option that you can use to basically calculate the dynamics of the tailings mud flow volume and route that downstream in the domain. Again, for this option, you need to use the two-phase flow component, and you need to enter all this data into your FLO-2D model in the QGIS tool. It's important to mention that if you decide to go this way and use the two-phase flow component, this is a very nice component. that where the mud flow concentration by volume varies with time and space. That means in the grid elements, you can vary the mud flow concentration by time and space. And this is something that make FLO-2D, the FLO-2D two-phase flow component a pretty unique product, since other commercial software using other tools to simulate the tailing dam failures do not have this capability. Also, the mud flow concentration by volume varies in the two-phase flow by grid element and time. So in other words, the sediment volume is tracked by grid element for each phase, because the two-phase flow component has two different phases, and we have a complete webinar on this. And so the sediment concentration is known at all times everywhere in the domain, okay? This, again, this makes FLO-2D two-phase component a very robust component to simulate tailing dam failures. But again, you need to enter some additional data, and it's a little bit more complex than the option to simulate the mud flow, the tailing dam failure using the tailing dam tool. And I'm going to talk specifically about the tailing dam tool in this presentation. If you want to go this way and use the two-phase flow component, Karen or myself can share with you different webinars and recordings and presentations about how to use the two-phase flow component in the FLO-2D Pro model. Simulating, you can also simulate a tailings dam failure using the tailing dam tool and the FLO-2D model. And in that case, is the tailing dam tool that I'm going to talk today about it, that allow you to create a inflow that hydrograph. Okay, so the tailings material is added to the FLO-2D model as a hydrograph. You don't need to enter the characteristic, the properties of the tailing material, or you don't need to enter basically the tailing material in the FLO-2D domain. You will only impose the tailing release volume as a hydrograph, as you can see in my slide, in my image here. Okay, so the tailing dam tool allow everyone to simulate a tailing dam failure without entering too much data for the tailing material. In other words, we use for this tailing dam tool some database from references, and we calculate a release volume from the tailing facility that is estimated by using empirical relationships between the release volume and the depth of the tailings. Okay, so what you in this case, if you decide to use the tailing dam tool to generate the hydrograph and impose the hydrograph as a boundary condition to the FLO-2D domain, you will need to calculate the hydrograph of tailing flow using the tailing dam tool. You will need to enter that hydrograph as a boundary condition that has that the hydrograph has water plus the tailings, and is created or exported to the inflow.dat file from the tailings dam tool. And then once you have imposed this hydrograph that again is created from the tailings dam tool as a boundary condition to the FLO-2D domain, you can route the mud flow downstream in your FLO-2D domain. Okay, so in this case, what you need is the tailings dam tool plus the FLO-2D Pro model that will help us to route the mud flow downstream in the domain. Okay. The FLO-2D Tailings Dam Tool is a tool that is based on the historical data, historical information, okay? And typically, if you see the historical information for the tailing dam that have failed in the past, the breach volume or the release volume is typically between 10 to 35, 40%, okay, of the impounded tailings volume, okay? And in this case, for the tailings dam tool, we do several things with this tool, okay? We first predict the potential of the likelihood or the probability for the tailings dam failure to occur. And I'm going to talk extensively about this and how we do it, okay? We also predict the release tailings dam volume based on what? On empirical correlations or empirical equations that use documented tailings dam failures, okay? Why is this important? Well, to have an accurate prediction of the tailings dam volume that is released downstream in your domain plays a critical point to basically to have a good estimation of the inundation mapping downstream. Okay, so the flow hazard prediction, if we want the flow hazard prediction to be accurate, we need to estimate the volume that is entering the system correctly, and this estimation is really difficult it has a really high uncertainty. It's difficult to make, and so that's why we create this tool. Okay, in the tool also you will need to select a discharge and a sediment concentration hydrograph, and we will use some typical hydrograph to distribute that release volume, and you will see that in a minute. Okay, then we use the FLO-2D model to route downstream to route the mud flow downstream. Okay. How to estimate this tailings release volume is difficult. As I mentioned before, is the uncertainty is high, and typically this empirical correlation estimate a volume that is between 30–50%, but we have some other cases where the volume released from tailings dam failures is closer to 70% of the volume that is available in the tailings facility. So it's really a difficult topic. The intention, as I mentioned before, is to generate the inflow.dat file that is just a boundary condition for the FLO-2D model to route this volume downstream in the system. And always you can compare the volumes and make sure that you are doing a good estimation of the volumes. To put together this tool, we analyze the failures of tailing dams that have been documented over the last few decades, and we categorize and analyze the different failure modes. So we put together the data and we analyze, okay, how many of these tailings dams are failing because of heavy rain or because of piping, sorry, or foundation failure or earthquake, or any we categorize the failure modes, and we group the tailing dam failures in different categories. And you can see in my table that the heavy rain, the piping erosion, and the earthquake are basically the most common cause of failure. So we have the extreme hydrologic events, piping erosion, and foundation design failures and earthquakes as the most common cause of failure for tailings dam facilities. So based on this table and on this information, we selected the most common causes of failure, and we ended up with 3 different failure modes, okay? What exactly we developed for these 3 failure modes? Well, we developed 2 things. We developed an event tree that predict the occurrence of the failure. We use different formulas to calculate the potential occurrence of each failure mode. And with the data that is provided by the user in the tool, and I'll show you that in a minute, we, for the different failure modes, for example, for the hydrologic failure, we calculate some we ended up calculating some different processes that are calculated behind the event treats that I'm going to show you, like, for example, the overtopping or the potential blockage of the spillway for hydrologic failure. Or we calculate also the what is the probability of a slope stability for the static failure, or if it's possible to have a deformation of crest and foundation liquefaction for a seismic failure. So we do all these kind of calculations behind the tailing dam tool, and we produce a probability or a chance that the tailing dam tool, that the tailing dam that you have fail. Okay, well, so we have this as the first product of the tailing dam tool. Okay, so the first product of the tailing dam tool is the probability or the chance that your tailing dam fails for a selected failure mode that you decide to select at the beginning of the process. Okay, and I'm going to show you this in a minute in the tailing dam tool. Okay, I know that it could be not too much information for before actually looking at the tailing dam tool. The second product of the tailing dam tool is using empirical formulas to calculate the estimated release volume. We basically estimate a volume using different empirical formulas, and I'll talk about that in a minute. Okay, so empirical formulas, empirical relationship, empirical equations. We put together some of these empirical equations. The ones that you see in my screen right now are basically the empirical equations that we calculated in our team with engineering analytics. That is a firm in Colorado that worked with us in this effort. And how we did this? Well, we extracted from the bibliography all the most recent failures, and we correlated the release volume with the dam height, and we ended up for the different failure modes, hydrologic, static, and seismic, with a equation, a formula that tell us the volume based on the height of the dam for a particular failure mode. Okay, and this was done by us. We also use other formulas, other correlations, okay, that like the ones from the Pichulo paper. This comes from a paper from the engineering geology, and the title is A New Look at the Statistics of Tailing Dam Failure. If you are interested to see this paper, let us know, and we can share with you the reference. In this case, this paper present different additional cases, additional also data for tailings dam facilities, because this use a newer database for the tailings dam failures than the one that we used back 5 years ago or 6 years ago. This is more new data, and they use this new extended database of tailing dam failures to calculate empirical equations. Okay, so you can see how some of these empirical equations are based in different number of failures. So they analyze a different number of failures of tailing dam failures. Rico et al., for example, analyzed 22 failures and provide this equation that you can see in my table. And this is in this paper also. Laruri and Lowell used 28 failures, but this paper in particular extended the number of failures to 70 and provides some new correlations based on that extended database of tailing dam failures. So it's a pretty good work what you can see in this paper. To do all these correlations, as I mentioned before, they recompute the volumes and they use an extended cases. Some of those extended cases are the the tailing dam failure for Brumadinho, for example, from Las Palmas, Fundao Dam, and different cases. So all this data is used in one of these equations to that was used to calculate, to estimate again the correlation equation for this updated data set. So, and we have that in the tailing dam tool now. If you see in your tailing dam tool that those equations are not included, it's because you are using the an older version of the tailing dam tool. So let us know, and we'll provide you with the latest version. Okay. As you may know already, the QGIS plugin has all the editor functions and also includes the tailing dam tool. Okay. And this plugin that you can see here is the newest plugin of the FLO-2D model. And this is plugin version 115. Karen can basically correct me if I'm making a mistake here with the plugin number. And this plugin includes the tailings dam tool. So when you click on the run tailings dam tool, the tailings dam tool is going to open, and also the plugin is going to let you to basically establish the settings for running that you want to establish in your simulation. And I'm not gonna spend too much time talking about that. As I mentioned before, and this is important, we already have a hands-on lesson in our share file. At the end of this presentation, I have that information for you, and that is a step-by-step lesson about how to use this tool. And it helps you to create from scratch a simulation using the tailing dam tool, and it's a complete FLO-2D tailings dam tool application, okay? Because in this presentation, we'll be covering pretty much the theory, and I will show you where the tailings dam tool is located in your computer if you have it already. Okay, so the dam geometry dialog box, once you click on Run Tailings Dam Tool, okay, the Tailings Dam Tool is going to open. You will see this first dialog box where we have the engineering analytics and our logo, and is basically the first dialog that opens when you open the Tailings Dam Tool. Then you will see this, okay? And this is the dialog where you need to enter the parameters, the data fields that will enable the user to, that will enable you to basically select from a range of values different options, okay? So this data that you need to enter here is includes dam geometry, like the dam height, the impoundment volume, water surface freeboard, the depth to bedrock from base. It will also ask you about tailing saturation. You will need to enter the shear strength, the impounded water at the dam face. You know, different data parameters related to geometry and the tailing properties that the tool needs to calculate all these formulas and predict if the failure is going to happen or no, okay? If you don't know, if you are not sure what data is this or what we are asking you to enter in one of these boxes, you can always click the question mark, okay? And this will help you to easily understand the required data, because it will show you an image that illustrates the necessary data. And I'll show you that in the next slide. In file, you can, once you enter the data, you can save that, okay, in a data file, so you can retrieve the data back to the tailings dam and open the data into the tailings dam tool later if you decide to close the tool and open it later in time. Or you can also play with options and change the units from English units to metric units, etc. Okay. Once you are ready and you enter all the data, you have to click next, okay? This is what, if you don't know, what data the one of these boxes is asking you about, you can always click on question, and this nice comprehensive image will show you an illustration of what data is needed in this case. Okay, so this helps a lot. Failure modes. Once you click next, let me go back one more time. Once you click next in this dialog window, you will see this information, okay, for the tailings dam, in the tailings dam tool. And this has different sections, okay. The first one is the failure modes. You will be able to click on hydrologic, static, or seismic, and the information here will change, okay, depending on what is the failure mode that you selected. In this case, I have selected hydrologic failure mode. So the data for hydrologic failure mode is shown in this slide, okay? So once you select the failure mode that you want to use, the data needed is going to be displayed. In this case, the available storage is calculated from the provided data in the dialog 1 of the Tailings Dam tool. So in other words, this data is used to calculate it for you, the available storage. You need to enter the input flood event volume. You need to select if a spillway facility is in your tailing dam or no. You will also need to enter the maximum allowable head and the PMF's water surface elevation. And with this data, with all this data, the tailing dam tool calculates some physical processes for the hydrologic event, and it will tell you if the failure is going to happen or no, and where that information is located in here. Okay, so once you enter all the data, the tailing dam tool will display the occurrence of the failure in this area. Okay, so you will see in the bridge type, dam breach by erosion or no dam breach at all. Okay, so if you see a no dam breach, that means that the probability, the chance of your tailing dam to fail is basically zero. It's not happening. There is no chance that tailing dam is going to fail based on the data that you enter in your tailing dam tool. Okay, if you see that the dam breach is going to has a potential to fail based on our calculations, basically you need to use these volumes that you see here in my slide to select the volume that will be used in the hydrograph for your simulation, okay? And let me talk a little bit more about that, okay? As I mentioned before, this probability of failure is based on an event tree analysis, okay? And that event tree analysis is basically a diagram that goes through a series of events or branches, you can call it branches, that trace forward through an event chain, okay? And you will see that in a minute, okay? In this particular case, the methodology that we use to generate that event tree concept is basically the U.S. Bureau of Reclamation and the U.S. Army Corps of Engineers methodology that they use for dam safety risk. So we use that methodology to basically generate our event tree analysis, okay? But again, the final, and you will see that in a minute, but the final product of this tool is basically the calculation of these volumes, okay? And these three volumes that you see in my red square here at the top of my slide are basically the minimum volume, maximum volume, and average volume that I calculate, that the tool calculate based on the empirical correlation that FLO-2D team put together, okay? And when I'm talking about those, I'm referring to these formulas, the minimum, lower, average, and upper bound of these formulas based on these three different failure mode events. Okay, so those are the formulas that we use to calculate this minimum, maximum, and average volumes. Okay, the other formulas that you see in this slide are basically the formulas that comes from the second plot or second image that I'm showing you here from the Pisulo paper, okay? So in this case, in these formulas, you can see from the different people, from different research, you see different volumes based on, and those formulas are empirical correlation based on, different subsets of tailing dam events that happened in the past, and that this research analyzed to generate their empirical correlations. Okay, but also with this latest version of the Tailings Dam tool, you could enter your own volume. Okay, that means that if you don't agree with some of these equations and you want to do your own empirical correlation, you can do it. You can calculate a volume and you can enter the volume here and use this volume to route the flow downstream in the FLO-2D model. Okay, so once you have all these calculations done in your Tailings Dam tool, you have to click create inflow that file. Okay, and before we go to create the inflow that file, I want to show you the event tree key concept that we use. Okay, so this, as I mentioned before, this is a comprehensive approach that we use based on the methodology from the U.S. Bureau of Reclamation and the U.S. Army Corps of Engineers in dam safety risk to generate these event trees. Okay, and this is for the hydrologic failure mode. You can see how all this happens when you when you change the hydrologic, static, and seismic failure modes on the top of this tool. Okay, when you go and change this, the tool goes through all these calculations and predict the occurrence or not of the failure for the tailing dam. Okay, and for each of these branches, we calculate different things in the background. Okay, so we go and see if you click that in the tailing dam tool, if you selected that the tailing dam has a spillway, then we take the tailing dam tool, take this branch, and then if the spillway is having a blockage, is basically blocked or has a potential block, then we follow this branch, and then we route the flow through the spillway, and if the spillway is exceeded, then we immediately follow this branch, and the tool basically tell you that the tailing dam is going to fail because the spillway is not able to route the flow that the excess flow from the tailing dam tool. If you say that, yeah, the spillway can route this excess volume, then we take this branch and we see, okay, the spillway passed the peak flow, yes or no, and we follow all these branches, okay, to basically predict the chance that this tailing dam is going to fail or no. Okay, this is for the hydrologic failure. You can see the different factors that we use to calculate the chance of failure for a particular tailing dam tool, based, of course, on the data that you provided in the tailing dam tool. Okay. We also have the static failure. In this slide, you can see the different factors that we use and the calculation that the tool defined to use to define the chance of the failure. And you can see that we basically use the reservoir level, the pore pressure. We calculate if the foundation is basically has any chance to fail or no. We have some also equation for the slow failure. And at the end, the outcome of this event tree is the occurrence of the failure or no. And this information is reported in this part of in this section of the tailing dam tool, okay, where you see failure information. It is in here where we report the occurrence or not of the failure. For the static failure, we base our calculation on different factors. You can see that, and if you want more information, you need more information regarding this, I can provide it, or Karen also can provide it. For the seismic failure, we use several methodologies several methodologies were compiled at the time when we start putting together this tool to basically calculate the potential for the seismic failure, and the event tree dialogue that you see in my the event tree that you see in my diagram that you see in my slide, taking into account different things like the earthquake loading, the deformation of the crest, if the foundation or the embankment has potential liquefaction or no. So we do several calculations on the background of the tailing dam tool to predict the probability of the failure. And once this is predicted, again, we use the empirical relationship to correlations to estimate a minimum, maximum, and average volume, okay, for the failure. Again, the factors used for the seismic failure are the ones that you see in my slide. And after we go through all this process, we calculate the chances to have a failure based on all the data that you provide and on the failure mode that you selected. And once you have that, we basically are at the stage where we can calculate the FLO-2D file, that is the second product of this tailing dam tool. Remember, the first product is the prediction or that this tailing dam tool that you are basically analyzing is failing or no, okay, it has a failure or no, based on what? On all the data that is provided and on our failure modes and the event tree diagrams. The second product is the FLO-2D file, okay? So in this, once you click, let me go back one more time. Once you click create FLO, okay, we have all these volumes calculated from the different empirical correlations. We click on create FLO-2D, and this dialog is open. In this dialog, we need some additional data, okay? Why? Because at this particular moment, we are ready to select the bridge volume, okay? And the bridge volume that needs to be selected comes from this drop-down menu, okay? If you open this drop-down menu, you will see something like this, okay? Where the different correlations equations are displayed, and the volume from the different correlations equation, empirical equations are displayed, and you can select one of those, okay? So that's the volume that we will be using for our mud flow simulation, okay? But that's a volume, right? We need to distribute that volume into a hydrograph, and we have in our tool 6 typical unit hydrograph shapes that presents a variable time of peak discharge that we provided with the tool, and you can see them, okay, in my screen. They are let me go back. These 6 are the 6 different hydrographs that we provided as typical hydrograph for your failure, for your tailing dam failure, okay? So in this case, the volume that is selected is distributed in this. If you select the first one, it's going to be distributed into this hydrograph. If you select the second one, third one, the distribution of the volume will happen, okay? We have an iterative a routine that was created for the tailing dam failure tool, that once you select the volume and you select the typical hydrograph, we will calculate what is the necessary peak that we need in order to accommodate the volume, the whole volume that you select here behind this curve, okay? So under the curve, basically. So in this case, you of course will ask me, well, what is the hydrograph shape that I need to use? Well, we don't know, right? You need to use professional judgment to select the hydrograph shape, and you will need to select the hydrograph shape that is the best option for the conditions that you have in your tailing dam tool, right? So if you want to generate a worst case flow hazard scenario, for example, you may want to select the front loaded hydrograph, okay, where the volume is going to release pretty quickly in your system and is going to move downstream pretty quickly in your system, okay, in your domain. One of the beauties of this tailing dam tool is that you can select different hydrograph, and you can run pretty quickly the FLO-2D model with this mod flow condition, and see what is the hydrograph that is giving you the worst case scenario, the worst case flood, okay? So, but also in this case, we need some data. Let's talk about that data. First, you need to select the volume that you want to use in your simulation. You also need the entire event time, that is, it goes here in this box, okay? And if this is 1 hour and you select these hydrographs here, that means that this entire volume is going to be released in 1 hour, okay? So this time here will be 1 hour if you select 1 hour. If you select 10 hours, then the release volume is going to happen in 10 hours. But we know that these failures are typically pretty fast, okay? Pretty quick events. The porosity, again, we recommended to use 0.4, but you can play with that too. The maximum sediment concentration, also, the default value is 0.5, okay? So we recommend you to use 0.5, but you can just increase that a little bit, 0.55, 0.6. Then you have to select the output format for the sediment, and this is the output format that will be used for the inflow.dat file, for the sediment field in the inflow.dat file, okay? And I'll show you that in a minute, but you can select sediment concentration by volume or sediment volume, okay? And also, if this volume is really large, typically these are large volumes, and the peak is a really large peak, you may want to enter that flow and sediment into different cells in the FLO-2D domain, right? You don't want that huge, large, very large volume to enter as a boundary condition into a one single cell in FLO-2D. So you may want to divide this hydrograph between 10 cells, 5 cells, a number of cells, to enter the volume into the, or the flow into the FLO-2D domain. So if that is what you want, you need to add the different cells here. And I prepare, okay, the different cells here. So that's the FLO-2D inflow grid element. That means that this volume will be divided between 3 different cells, okay? And those inflow hydrographs will be assigned to these 3 different cells, okay? So then we divide the flow into 3 different cells in the FLO-2D model. Porosity default 0.4, I talk about that, and the final product will be the inflow.dat file format, okay? And again, the format for the sediment in this file could be sediment concentration by volume or sediment volume, okay? And what option do I need to take? Well, it's up to you. If you want to use sediment concentration by volume, you see that your sediment concentration will go, the range will go from between 0 and 1. And if you want to use volume, then that will need to be entered in cubic meters or cubic feet, and the tool will create that volume for you, okay? And you will see that in a minute. So once you have this, you save the inflow and you have the inflow.dat file. But before you do that, we also let you to enter a distribution for the sediment concentration. Okay, so you can see you have 6 different sediment concentrations in here, and you can enter the sediment concentration distribution that you want to use in your simulation. Okay, the product, the final product, the final product that this tailing dam tool generate and create for you, okay, is a inflow.dat file. It's basically a data file that contains the inflow hydrograph created using the volume that is going to be released from your tailing dam failure. Okay, so this inflow.dat file can be used or should be used as a boundary condition. You should add, you need to read that inflow.dat file and assign it to your FLO-2D model. So that volume, that hydrograph that is imposed as a boundary condition and that contains basically the release volume from your tailing dam, will be routed in the FLO-2D model downstream as a mod flow and will create basically the basically the inundation area and all the results for your FLO-2D model. But now let's talk a little bit about the format of this file, okay? The typical, and for those of you that are familiar with FLO-2D, this is basically information that is not essential, but those of you that are just new in FLO-2D, is good information for you guys. So in the first line, if you open, after you create this inflow.dat file from the Tailings Dam tool, if you open the inflow.dat file, you will see a first line that it has 2 variables, okay? The first variable is the hour daily, okay? And you don't need to understand any of these variables. You don't need to learn these variables and memorize anything because this is created for you, but I just want you to understand what we are doing here, okay? So this first value is 0 if the data is in hours or 1 if the data is in days, okay? In our case, the data is in hours and you will see that in a minute. The IDEP-LT is the grid number, okay? And this grid number is the inflow grid element number whose hydrograph is to be graphically displayed at runtime, okay? So that means that if you have many inflow hydrographs here, you need to select one that will be displayed at runtime. That's all it means, okay? So the second line is the green line that you see in my screen is the F line. F or C means that or identify that this inflow hydrograph element is assigned to a floodplain if the line starts with an F, or a channel if the line has a C, okay? A channel element or a floodplain element. The second value is the in-out FC. That is telling me the type of condition that we are imposing with this hydrograph. It goes from 0 to 3. 0 is an inflow, that is the one that you see here. This is an inflow hydrograph. 1 is a diversion hydrograph. 2 is a source hydrograph, and 3 is a sink hydrograph. And those source and sinks are for groundwater, and they are not used in the tailings dam tool. So for the tailings dam tool, this will be always 0, okay? Because it's an inflow hydrograph, what basically the condition that we are imposing in this case. This number that you see here, 37,478, is the inflow node. That means that this hydrograph that you see in my screen, in my slide, is going to enter the FLO-2D domain at this cell, okay, through this cell. So in this case, we are using one cell, okay? If you select several cells in here, this hydrograph, you will have several inflow hydrograph here. You will have one assigned to 37,478, another one assigned to 37,477, and so on, okay? The H line are the time discharge sediment lines, okay? So are the sediment for each hydrograph, okay? And in the first column, you see the H, that's just an identification of the hydrograph data pair. 0 is the first time, okay? It's in hours, so it goes from 0, 0.06 hours, 0.12 hours, goes all down to 1 hour. And the third column, 27.5, 123.7, those are discharge, water discharges, okay? So it's basically CFS or CMS. And the last column is the sediment concentration, in this case, enter as a sediment concentration by volume, okay? If you decide to select here sediment volume, then you will see here volumes in cubic meters or cubic feet, okay? And the tool does that for you automatically. You only need to understand what you want to see in your inflow.dat file, because the tool will create that in the format that you select. Okay, so now that we have this inflow.dat file, we are ready to assign, to take this inflow.dat file to your project folder by reading the inflow.dat file back into the QGIS plugin. And that's something that we show step by step in our hands-on lesson, the one that I'm going to share with you at the end of this presentation. And then we are ready to run the FLO-2D model, okay? So you run the FLO-2D model until completion. You know that for this particular case, my mod flow hydrograph is entering this volume in 1 hour, because I select 1 hour as the entire event time, but you can run FLO-2D for 3 or 4 or 5 hours and see how this mod flow is moving downstream in your system. And then after you finish that, I always recommend you to review the summary dot out, okay? So again, the FLO-2D is going to route this mod flow downstream, and you are going to be able to see the mod flow progression in your system. The Tailings Dam tool, as I mentioned several times, help you to create the inflow.dat file and to double check that the tailing dam based on the data that you have is failing or not. Okay, so the currency of the failure is basically predicted by the tailing dam tool. And once you run the model and you have all your output files, the model, basically the FLO-2D model, will allow you to check the area of inundation, and all the hydraulics associated with the tailings dam scenario that you run, okay? If you want to plot all these details, all these output files from your simulation, we have several webinars and examples, lessons that can help you out to plot and to analyze and all the data that is created when you run the FLO-2D model. So just let us know if you need assistance getting those recordings and lessons. As I mentioned before, it's always good to check the release volumes, okay? And the FLO-2D model route the flow, calculate all the physical interaction of the mod flow release, but also reports the total volumes. And those are the total volumes that are moving downstream in the simulations, okay? And those volumes, the total volumes, are reported always to the summary.out file. That is an output file, okay? And if you open your output file, you will see that there is reported the stored water, the water plus sediment. And if you take the bulkhead volume minus the water, you will have the tailing solid sediment volume, okay? Not adjusted for porosity, of course, in this case. What is how is this volume? What is the percentage of the available material that is going through the bridge? Well, this is something that can help you to basically calculate the percentage of that tailings, okay? And typically is between 30 to 70%, okay? So check the total volume from your model results and compare that with the volume that you estimate from the Tailings Dam tool, and calculate that from the volume that you estimate. So in this case, the total volume from the model results can be compared with the tailing volume And basically, I'm not going to spend too much time in this slide, but if you need assistance after you run your model understanding the volumes, just let us know and we'll basically give you some advice. We have different presentations that explain how to compare these volumes, okay? But remember, it's important to compare the volume and make sure that we have an accurate estimation of the volume, because the volume is going to define basically the area of inundation, okay? So it's really important to have a good estimate of that. Recommendations. Start simple, then develop the worst case scenario, okay? So create the FLO-2D model domain, work with the tailings dam tool by generating a mud flow hydrograph from tailings dam breach scenario. Add the tailings dam hydrograph as a boundary condition to the model domain. Run the FLO Pro exe, that means run the FLO-2D model, okay? And always check the volumes, make sure that the volumes that you enter and select from the tailing dam tool is basically the same volume that is being distributed and routed downstream in your system, because again, if you are accurate with your volumes, the area of inundation and the mud flow extension will be also accurate. So it's really important to make sure that the volumes agree, okay, as well as to check that we have volume conservation in the system. FLO-2D is a model that conserve volume all for all the different components. Add rainfall. Then once you are happy with your volumes and you are happy with your simulation, you check your volume, you check your area of inundation, and you are happy with the tailings dam analysis. In this, of course, in this part of the approach, you can always run different scenarios, different failure modes, different volumes distributed with different hydrograph. You can start adding more details to your system, like adding rainfall, add additional inflow hydrograph, for example, high volumes, water volumes that are coming from upstream basins. Add surface component like urban features, 1D channels, bridges, channel, 1D channels, streets, levees, or any other additional feature that you want to add to your system, okay? Then you can run the FLO-2D model again and mapping the results, and start just doing your analysis, finishing your analysis. It's important to highlight here, or at least this is something that I want to highlight, that this tailing dam tool is a tool that help us to define the inundation map and the typical scenarios, or several scenarios in a very simple way, okay? Just without needing too much detail or too much data. So it's a screening tool, basically. Again, we go back to this point where we need to highlight that this is a screening tool that helps us to run pretty quickly different scenarios, different runs, and define the worst case scenario, okay, in a very easy and fast way. The final product of the tailing dam tool, again, is the bridge hydrograph and sediment concentration that constitute the boundary condition, is the volume of water and sediment that will be routed downstream through the project area using the FLO-2D model, and will help you to analyze and to define the flood hazard and the inundation extension of your mud flow, okay? What other resources are available for not only for the tailings dam, but I'm going to talk today about specifically tailings dam, but we have these resources available for all of our components, okay? You have to visit our FLO-2D FTP to download additional information. We also have YouTube videos if you subscribe to our YouTube channel, you may be able to see, you will be able to see our recordings and our new webinars and old webinars. Most of them are there. We also have in our FTP example projects, PowerPoint presentation, webinar recordings, the QGIS plugin, and of course the executable that we try to release a new executable every year with different new improvements and enhancements. We also have a PPT presentation for tailings dam bridge modeling, okay? That covers not only the tailings dam tool, but also the two-phase flow, the mud flow, sediment transport. You know, it's a very complete series of webinar. I think it's like a 4 or 5 webinars all together with the lessons and all the material is available. So this is a pretty good comprehensive material that will help you to understand these components and what are the different options to simulate tailings dam failures in FLO-2D. We also have a documentation site, a documentation website with tutorials, okay? That is the documentation.flo2d.com. In that documentation website, we have one particular application for tailings dam tool, okay? And we also have this tailings dam tool application recorded. We have a recording for that tailings dam tool, and this is the link that Karen mentioned at the beginning of this webinar that contains the tailings dam tool application. Step by step from scratch, you can build a tailings dam tool application in FLO-2D, okay? So this is all I have for today. I'm gonna stop the recording, Karen.